Hi everyone, welcome back. In this video, we are going to discuss top 20 Java OOP and design patterns interview question. Let's begin. What are the 4 pillars of OOP? The 4 pillars of object-oriented programming are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation means bundling data and behavior and hiding internal details from outside access. Inheritance allows one class to acquire properties and behavior from another class, enabling code reuse. Polymorphism allows the same method call to behave differently depending on the object executing it. Abstraction hides complex details and exposes only the essential features. These pillars help structure applications in a modular, scalable, and reusable way. They enable developers to build systems that are easier to maintain, extend, and test because responsibilities are distributed across specialized classes. Interviewers expect you to explain not only what each pillar is, but also why they are important. They reduce complexity, improve code clarity, and support clean architecture. Understanding these pillars is fundamental because almost every Java design decision is influenced by them. Next, what is encapsulation and why is it important? Encapsulation means restricting direct access to an object's internal data while providing controlled access through methods such as getters and setters. The goal is to protect the object from accidental modification and maintain a predictable state. By hiding fields and exposing only required operations, encapsulation reduces coupling and improves maintainability. It also allows developers to add validation or business logic without altering external code. For example, instead of allowing free access to a field, adding a setter lets you validate input before accepting it. Encapsulation also increases security by preventing external classes from misusing internal data. In interviews, emphasize that encapsulation enables loose coupling, prevents inconsistent states, improves debugging, and allows future changes without breaking existing code. It is one of the foundational principles that make OP systems stable and flexible. Next, what is inheritance in Java and when should it be used? Inheritance allows one class to extend another, reusing its fields and methods. It helps share behavior among related classes and reduces code duplication. A subclass inherits capabilities from its parent and may override or add new behavior. However, inheritance should be used carefully. The relationship must represent a real is-A hierarchy. Misusing inheritance often leads to fragile designs because subclasses may unintentionally break parent behavior. When you need reuse without strict hierarchy, composition is usually a better alternative. Interviewers expect you to highlight both benefits and risks. The benefit is reuse and polymorphism. The risk is tight coupling. You should mention that inheritance is ideal when the subclass truly shares the same identity and behavior model as the parent class. Otherwise, use interfaces or composition. Next, what is polymorphism in Java? Polymorphism allows the same method call to behave differently depending on the runtime object. It enables flexibility and dynamic behavior in applications. For example, different subclasses may implement the same method with different logic. When calling a method through a parent reference, Java decides which version to execute at runtime. This supports loosely coupled designs and increases extensibility. Interviewers expect you to clearly distinguish between compile-time polymorphism, which includes method overloading, and runtime polymorphism, which includes method overriding. Polymorphism is essential in design patterns such as strategy, template method, and command. It allows applications to evolve without modifying existing code because new behaviors can be added through new subclasses. This is one of the key reasons OOP is powerful. Next, what is abstraction and how does Java support it? Abstraction hides complex implementation details and exposes only the necessary behavior. In Java, abstraction is achieved using abstract classes and interfaces. These allow developers to define a contract without specifying the full implementation. This leads to cleaner designs where the what is separated from the how. Abstraction reduces complexity by allowing developers to think in terms of high-level operations rather than low-level steps. It also enables flexibility because multiple classes can implement the same abstraction differently. Interviewers want you to say that abstraction improves scalability, reduces coupling, and supports clean architecture. It is used everywhere in Java frameworks including JDBC, Collections, Hibernate, and Spring. Next, what is the difference between composition and inheritance? Inheritance models an as-I relationship, while composition models a has-a relationship. Inheritance reuses behavior by extending classes, but it creates tight coupling because subclasses rely heavily on parent implementation. Composition allows a class to use another class as a field, making the design more flexible. Modern design principles prefer composition over inheritance because composition allows changing behavior dynamically and avoids accidental dependency issues. For example, adding or replacing a component is easy with composition, but risky with inheritance. Interviewers expect you to say that inheritance should be used sparingly and only when a true hierarchy exists. Composition gives better modularity, testability, and reusability. Next, what is the difference between an interface and an abstract class? An interface defines a contract that implementing classes must follow, while an abstract class provides partial implementation that subclasses extend. Interfaces support multiple inheritance, whereas a class can extend only one abstract class. Abstract classes can have state and constructors. Interfaces cannot hold state except through constants. Interfaces suit behavior definition, while abstract classes suit shared base behavior. Interviews often expect you to highlight when each should be used. Use an interface when unrelated classes share the same behavior. Use an abstract class when related classes share common code or fields. Next, what is method overloading and overriding? Method overloading occurs when multiple methods in the same class share the same name but differ in parameters. It enables compile time polymorphism. Overriding occurs when a subclass redefines a method from the parent class with the same signature. It enables runtime polymorphism. Overloading increases readability and usability of APIs. Overriding allows customizing inherited behavior. Interviewers expect you to explain how overriding supports dynamic polymorphism and why it is central to OOP design patterns. Next, what is the Liskov substitution principle? LSP states that a subclass should be usable anywhere the parent class is expected without breaking functionality. Violating LSP leads to unpredictable behavior and fragile inheritance. This principle ensures safe polymorphism. Interviewers often use examples like rectangle, square, or bad inheritance hierarchies to test understanding. The key point is that subclasses must honor all expectations of the parent class and should never weaken or alter core behavior in incompatible ways. Next, what is the open as closed principle? The open closed principle says classes should be open for extension but closed for modification. This means you should extend behavior by adding new classes instead of modifying existing ones. This principle helps maintain stable code and prevents breaking existing features. It is used heavily in design patterns such as strategy, decorator, template method, and factory. Interviewers will expect you to highlight how OCP reduces regression issues and promotes flexible architecture. Next, what is the single responsibility principle? The single responsibility principle states that every class should have only one reason to change. A class should handle exactly one responsibility. When a class has multiple responsibilities, changes in one area can break unrelated features. This increases coupling and makes testing difficult. SRP keeps systems modular and easier to maintain. Interviewers expect you to explain how SRP leads to cleaner architecture and why each module should focus on just one job. Next, what is the interface segregation principle? SP states that clients should not be forced to depend on methods they do not use. Instead of creating large interfaces, break them into smaller specific ones. This avoids forcing implementing classes to carry unnecessary methods. ISP improves modularity, reduces side effects, and makes code more maintainable. Interviewers expect you to recognize that many framework interfaces follow this principle. Next, what is the dependency inversion principle? DIP states that high-level modules should not depend on low-level modules. Both should depend on abstractions. Also, abstractions should not depend on details. Details should depend on abstractions. This keeps systems flexible and easy to change. Instead of tying logic to concrete classes, you depend on interfaces. This enables dependency injection and supports clean architecture. Interviewers expect you to emphasize why DIP improves testability and reduces tight coupling. Next, what is cohesion and why is it important? Cohesion refers to how closely related the responsibilities of a class are. High cohesion means a class focuses on a single task, while low cohesion means the class handles unrelated things. High cohesion improves readability, maintainability, and reusability. Classes with low cohesion are difficult to modify and test. Interviewers expect you to connect cohesion to SRP. Next, what is coupling and how can it be reduced? Coupling refers to how dependent classes are on one another. High coupling makes systems rigid and prone to bugs when changes occur. Low coupling means classes interact through stable abstractions. Coupling is reduced through interfaces, dependency injection, encapsulation, and modular design. Interviewers expect you to explain that good design aims for low coupling and high cohesion. Next, what are design patterns? Design patterns are proven solutions to recurring software design problems. They provide templates for structuring code in ways that improve reusability, flexibility, and maintainability. Patterns are divided into creational, structural, and behavioral categories. They help avoid reinventing solutions and improve communication among developers. Interviewers expect you to mention that design patterns are guidelines, not strict rules. Next, what is the factory pattern? The factory pattern is a creational pattern used to create objects without exposing the creation logic. It centralizes object creation in one place. This improves maintainability because adding new product types does not require modifying client code. Interviewers want you to mention that factory patterns support open-closed principle and reduce code duplication. Next question, what is the singleton pattern? The singleton pattern ensures only one instance of a class exists throughout the application. It is commonly used for logging, caching, configuration, and thread pools. Interviewers expect you to mention the importance of thread safety, lazy loading, and preventing multiple instances. It's also important to know that overuse of singleton can cause tight coupling. Next, what is the strategy pattern? The strategy pattern allows selecting an algorithm at a runtime. Instead of using if-else logic, each behavior is encapsulated into its own class. The client chooses which strategy to use, improving flexibility. This pattern supports open-closed principle and enables cleaner, more maintainable logic. It is widely used in sorting, payment processing, and business rule engines. Next question, what is the observer pattern? The observer pattern defines a one-to-many relationship where multiple observers automatically get notified when a subject changes. It decouples event producers from event consumers. It is heavily used in event-driven systems, GUI, and real-time updates. Interviewers expect you to explain that observers register themselves and the subject notifies them when state changes. These are the frequently asked interview questions on object-oriented programming and design patterns in Java.